Hello, ladies and gentlemen, and welcome back. Root Beer here, looking at B2 on our 2012 open paper. What have we got for B2? For each positive integer n, define phi of n to be the number of positive divisors of n. For example, phi of 10 is 4, because 10 has 4 divisors, 1, 2, 5, and 10. Nifty. Traditionally, phi is sort of reserved for another type of function, but it's not one that pops up in high school, so it's okay. Suppose n is a positive integer so that phi of 2n is equal to 6. So whatever n is, if you double it, you get 6 positive divisors. Determine the minimum possible value of phi 6n. Interesting. Okay, so what can we do? Well, we could, of course, experiment around. Can I think of something that has only 6 positive divisors? And you might say, well, how do I know what has 6 positive divisors? Well, if I prime factor a number into products of powers of primes, so each of these p's is a prime, and they're all different primes. So for example, something like 60 is 2 squared times 3 to the 1 times 5 to the 1. There's a unique way to write this. It's called the fundamental theorem of arithmetic. Not that relevant right now. But being able to break things down like this is, because I'm just going to write the 60 over here. Because if you can express a number like this, then the number of factors, which is exactly the function they're talking about, is written e1 plus 1 times e2 plus 1 times e3 plus 1, and so on, all the way up to ek plus 1, no matter how many primes you have. Okay? It's a really nice little trick. It helps with all these sort of counting the number of factors questions, and these pop up on some more advanced contests in high school from time to time. So for example, without writing them all out, I can see that 60 has 3 times 2 times 2, 12 factors. Okay? Take the 2, add 1, take the 1, add 1, take the 1, add 1, and we multiply them all together. Okay? So this is a nice, neat thing. Okay? Now, what are we talking about? Well, with phi 2n, we have 2 possibilities. Okay? It could be 2 to the 1 times everything that is n. But remember what I said, these primes have to be different. What if n is already an even number? So this would be 1 plus 1, which is 2, times, and then what do we get here? Phi of n. Okay, so that's possible, and so we'd get 2 phi of n. Or, so this happens if 2 doesn't divide n. Now, if 2 does divide n, then we could say, let's let p1 equal to 2. Then phi of 2n is going to be 2. We're going to gain 1 more 2 than we had before. And so my formula for, I don't know why I wrote equals, my formula is going to be off slightly. It's e1 plus 1 times e2, well, e1 plus 1 plus 1, which is e1 plus 2, e2 plus 1 all the way times ek plus 1. And so where's this going? Well, it turns out to be phi, so we can separate this out as to e1 plus 1 times the rest of this, plus, and then an additional 1, so this is phi n plus, I guess, phi of n over 2 to the e1. the sort of the odd portion of n. Okay. So these are possibilities. This is just me sort of rambling about the factor function. Now, what are we told? Well, we know that phi 2n is 6. Okay, so we might get phi n is 3, or we might get something else that I don't even know. Now, phi of a number is always at least 2, unless you're looking at the number 1, because 1 only has one factor. All right, for each positive integer n. Okay, all right. So it's entirely possible that this is 1, and then we've got 5 here. Or maybe this is 2, and phi n is going to be 4, and those sorts of things. So it's looking a little tricky to work out here, but okay. Now, what do they ask us about? Phi 6n. Ask about phi 6n. So that's phi of 2 times 3 times n. So again, depending on what n is, does it have is it a multiple of 2? Is it a multiple of 3? What might we have going on here? Okay, so we could have lots of things, really, but same sort of thing applies. So I'm going to write this as phi 3 times 2n, and I'm going to say something like, let 2n equal I'll use different primes. So q1 d1 times q2 d2 times qk dk. I might connect this to our earlier work, but I just realized we sort of really only need the 3. So if 3 does not divide 2n, then we can get 6n is 3 to the 1 times all this. And so phi 6n is going to be 1 plus 1 times whatever's left over is phi 2n. And I know phi 2n is 6. So I could get 2 times 6, 12. So 12 is a bare minimum answer. But it's not the only one we could have. So we could get something else here. Now, if, get another page, if 3 does divide 2n, then we could say something like, let q1 equal 2 and let q2 equal, well, let's let q equal 1. Q1 equal 3. Q2 equal 2. So then 6n is 3 to the d1. We've added in another one. And 2 to the d2. And times a bunch of other primes. Maybe. There might not be any other primes. And so then we'll get d1 plus 1 plus 1. And we're going to get sort of the same breakdown we had earlier. Phi n, and then phi n over its. So phi 6n is going to be phi n plus phi n over 3 d1. Get rid of the other factors of 3 here. Okay. Well, sorry, phi 2n. Okay. And we know phi 2n is 6. Now we want something sort of, so we want to do better than 12. Now, as I already remarked here, we can get it exactly equal to 1 if 2n over 3 to the d1 is equal to 1, but if that's not going to happen, because then 2 times something would have to be a power of 3, and that never works. So this is at least 2, so we can get at least 8. The question is, well, how can we do that? So can we get 8, or do we need more, I guess is the question. So phi 6n is equal to 8 if 2n over 3di is a prime. Because primes have exactly 2 factors, so phi of a prime would be 2. So we can't get rid of this factor of 2, so it's got to be equal to just 2 itself. So n is a power of 3. Now, can I get an n to be a power of 3 so that 2 times 3 to, I don't know, some power x, can I make it so that phi 2n is 6? Because this is an important question. If for some other reason that I haven't come across or thought through, 2 times 3 to the x will never give me a phi of 6, then I have to try something else. So we do need to verify this. But this would be 2 to the 1 times 3 to the x, so we'd need 2 times x plus 1. X plus 1 just needs to be 3. X needs to be 2. So 2n being equal to 2 times, so 18, and incidentally n is 6, or n is 9, should work. So 18 has 3 factors. And then if I multiply it by 3 again, 54, I should get the smallest number, 8 factors. So what would that be? That would be 2 times 3 to the 3, and then 1 plus 1 times 3 plus 1 is going to give me 8, and we didn't want the n's, we just wanted the smallest. So suppose n is to determine the minimum possible value, the answer is going to be 8. All right, nice question, good question, I liked it. Up next will be B3, so if you haven't given that a shot, please do so. Practice always does make perfect, and I will see you for more math, more Canadian Open papers in the next video.